Good day to our fellow students. Welcome to Study Talk. For this week's lesson, we are going to talk about operations on radicals. We have here Miss Labajo to start the lesson. But before we start, don't forget to hit the subscribe button and to turn on the notification bell so you are updated on our upcoming videos.
Hi students! As Ms. Gahalion said earlier, today we are going to talk about operations on radicals. Radicals have four operations which are addition, subtraction, multiplication, and division. But of course, for today's video, we are going to focus on the addition.
Good day to all. You can call me Sir Palacio. Here in our screen is an illustration of a radical. The N represents the index and the B represents the radicand. For example, if we have the same index and radicand like in the screen, we would just add the coefficient together, and in this case, we have the same index and radicand, so just simply copy the given radicand and index. And this kind of an example is called like radicands.
Hi, I'm Sir Gabriel, and for today, let's talk about unlike radicals. Like in the second question here in the screen, we can all see that we have the same index, but we have different radicand. Is it considered as like radicals? The answer is no. How are we going to solve it? The answer is we would simplify it and turn it into like radicals. And we have here Miss Gakutan for precise explanation.
Thanks, Sir Gabriel. And now let's proceed to the question. So as we all know, 48 is not a perfect square, but it has a factor that has a perfect square, which is 16 and 3, wherein 16 is a perfect square. So we have here 16a squared and 3b. Then just repeat the process in 27a squared b. Separate those, and simplify the expression which can be simplified. And that's how we would turn it into like radicals. After that, follow the steps like we did earlier in the first example, wherein the final answer is 7a square root of 3b.
And take note, in factoring, at least one term should be a perfect squared.
We are not just gonna end here. Let me give you a word problem. So there's a rectangular apartment in the city. Both two sides has a length of 15 square root of 50 feet. And the other two sides has a width of 11 square root of 32 feet. The question is, what is the perimeter of the room? This is Sir Andren, and let's all welcome Miss Gahalion to solve the problem.
Thanks, Sir Andren. But now, let's go back to the question. So there is a rectangular apartment in the city. Both two sides has a length of 15 square root of 50 feet, and the other two sides has a width of 11 square root of 32 feet. The question is, what is the perimeter of the room? As you can see, the 11 square root of 32 feet and 15 square root of 50 feet is not like radicals, which means we have to turn it into like radicals before adding it. First things first, let's write the given, which is 15 square root of 50 plus 11 square root of 32 plus 15 square root of 50 plus 11 square root of 32. And then, add the like radicals. 15 plus 15 is equal to 30, and just copy the radicand and index. And then, 11 plus 11 is equal to 22, then just copy the radicand and index. 50 and 32 is not a perfect square, so let's factor it. But keep in mind that one factor should be perfect squared. So the factor of 50 is 25 and 2, wherein 25 is the perfect squared. And the factor of 32 is 16 and 2, wherein 16 is the perfect squared. Then just separate both factors and simplify the terms. The square root of 25 is 5, while the square root of 16 is 4. Then multiply the terms, and now we have 150 square root of 2 plus 88 square root of 2, wherein it is now a like radicals. So just simply add 150 plus 88 and copy the given radicand index. And now, our final answer is 238 square root of 2 feet. And this is now the end of our topic for today, which is adding radicals. And that's all for today. See you in the next video. Don't forget to comment down below on what you have learned for today's lesson. Again, this is Study Talk.